Good morning, students. Welcome again to physics classroom. Today we'll begin from the assignment that I had given you in my previous class. An ebonite rod when rubbed with flannel acquires a negative charge of 4 nanocoulombs. How many free electrons can constitute this much charge? So the given values, Q is equal to 4 into 10 to the power minus 9 coulombs. As we all know that the value of elementary charge is 1.6 into 10 to the power minus 19 coulombs. Using these two values and the formula Q is equal to N into E, we can get 4 into 10 to the power minus 9 coulombs equals N multiplied by 1.6 into 10 to the power minus 19 coulombs. We can cancel out the units. Therefore, N is equal to 4 into 10 to the power minus 9 divided by 1.6 into 10 to the power minus 19. We get 40 divided by 16 into 10 to the power 10. Cancelling by 8, 8 5s are 40 and 8 2s are 16. So we get the final result as 2.5 into 10 to the power 10 electrons. So that is the answer for this question. As we had studied already that charges constitute current. Now the question arises, what type of charges are responsible for constituting current, whether they are the positive charges or the negative charges. As we all know that the positive charges are confined within the nucleus. So not being in the situation of moving freely, they could not constitute current. So the negative charges or the negatively charged particles, the electrons, are responsible for constituting current in any conductor. Now, how these electrons are moving inside any conductor, that you can understand with the help of this adjoining picture. You can see how these electrons are moving, and adding to it, they are also moving in one specific direction. Now, it is not possible for every electron to continue moving in the same direction all by themselves. So, obviously, there has to be some external agency that can possibly do this task. How this is achieved, that we will be discussing a bit later, but for the time being, we can understand that directed flow of charges constitute current. So now we can define electric current as charge flowing through a given cross section of a conductor per unit time. That will give us the measure of electric current. You can see in this picture how the electrons are moving inside the conductor. A very simple circuit has been shown, which is comprising of a cell, the wires and a bulb. So the electrons are shown by the blue dots. They are moving from negative electrode to the positive electrode of the cell. However, the direction of conventional current has been shown to be from positive to negative. Now this might be a bit confusing for you all, that why the direction of current is taken opposite to the direction of flow of electrons. When this direction was chosen, it was chosen arbitrarily. Actually, then people didn't even know that charged particles, rather electrons, are responsible for constituting current in any circuit. So it was very arbitrarily decided that the direction of conventional current is from positive to the negative part of the circuit. So that's why still the same convention is being followed, and the direction of current is still considered from positive to the negative part of the circuit, from positive terminal to the negative terminal of the cell. This needs to be remembered whenever we are drawing any circuit diagram and marking the direction of current. From the definition, we can obtain an expression for current as charge divided by time. Mathematically, current is equal to charge by time. I is equal to Q by T. I stands for the symbol of current. If we have obtained the expression for current, very easily we can obtain the unit. Unit of charge is coulomb, unit of time is second. So, coulomb per second, that should be the SI unit of current. Coulomb per second is called ampere and symbolized as A. Now, how to define 1 ampere? If 1 coulomb charge flows through a given cross section of a conductor in 1 second, current constituted is 1 ampere. We have followed the same formula, I equal to Q divided by T. Charge is 1 coulomb, time is 1 second. So, if 1 coulomb charge is flowing in 1 second, current constituted is 1 ampere. We need to remember that even though current has got both magnitude and direction, it has got a magnitude and the direction is from positive to negative side. Even though it has got both magnitude and direction, still it is a scalar quantity. Now, going by the knowledge about scalar and vector quantities that you have got in class 9, you know that any quantity that has got both magnitude and direction is always a vector, but in case of current, it is simply a scalar quantity. Why is it so? Because while finding the value of total current in any circuit, we cannot apply the rules of vector addition. We simply apply the rules of mathematical addition or the algebraic rules of addition. How two vector quantities are added, that you will be studying in detail in class 11th, but for the time being you should simply understand that current is not a vector, it is a scalar, pure scalar quantity. How current is measured? Current can be measured with the help of an instrument called ammeter. Now I am zooming the picture a little bit so that it becomes convenient for you all to see how the ammeter has been connected in this circuit. You can see there are two terminals, red and black. Beside the red terminal it is written positive and beside the black terminal it is written negative. So it has got two terminals, positive and negative. Adding with it there is a calibrated scale. The deflection of the pointer tells us what is the magnitude of current flowing in the circuit. Now there are two things that we need to remember while doing the connections of an ammeter in any circuit. It must always be connected in series. The manner in which you can see the connections of ammeter in this circuit, this is how a series connection is made. The positive side of ammeter must be connected nearest to the positive terminal of the battery or electric cell and vice versa. Now instead of using an ammeter, we can also use a Milli Ammeter or a microammeter, depending upon what is the magnitude of current flowing in the circuit. For measuring very small values of current in any circuit, we can make use of these two instruments instead of using an ammeter. Ammeter always measures the value of current in ampere, as you can see in the picture. Milli Ammeter measures it in milliampere and microammeter measures it in microampere. How a directed flow of charge is obtained? This question we need to answer, but prior to that we will go back a bit into the properties of charges. We had a lengthy discussion regarding properties of charges in the previous session. We'll try and continue with that itself. We'll understand the basic concept of a terminology that plays a dominant role in deciding how a directed flow of charge is eventually obtained in any circuit. So, for this we'll make use of a very useful simulation. This will help us to understand how a charged particle creates a zone of influence, a zone in which, a space in which the influence or force of that charge can be experienced. Now I am considering a small positively charged particle having a magnitude of 1 nanocoulomb, and you can see when this positively charged particle is kept in this region how it is creating a zone of influence. These arrows are actually representing the space in which the force applied by this charge can be felt. If I substitute this positive charge with a negative charge, a similar zone of influence will be created. Okay, the difference being between the zones or the direction in which the force is being applied by this charge is that you can see in case of negative charge the arrows are directed towards the charge, while in case of a positive charge the arrows are directed away. Now if suppose we are having both type of charges placed near one another, then you can see how this region will be created in which both the charges will be exerting some forces. So we can understand from this pattern or this simulation that a charged particle always creates a space around itself where its force or influence can be experienced. That particular region is called electric field. So electric field is the space surrounding a charge in which its force or influence can be experienced. Okay. Now one question might arise in our mind that what if we are having one positively charged particle kept in a certain region and we have to bring another positively charged particle from a far off distance into the electric field of this positively charged particle. That far off distance is called infinity, situated at a very large distance from this electric field. We have to bring that positive charge from infinity, that far off distance, into the electric field of this positive charge. So obviously as like charges repel each other, we have to do some work in bringing this positive charge from infinity to the electric field. That work done can be measured, and that work done actually is very important in deciding what is going to be the so called potential at any point. Electric potential. It is the amount of work done in bringing a unit positive charge from infinity to a given point in the electric field. In the picture, you can see that from infinity a positively charged particle is being brought into the electric field. Now this sort of a pattern you have seen in the previous simulation. So when the positive charge is being brought from infinity to a point inside this field, whatever is the amount of work done, that work done divided by charge gives us the value of electric potential at that point. So mathematically electric potential is denoted by V, and it is given by work done by charge, W by Q. It is a scalar quantity. Work done, SI unit is joule, and for charge SI unit is coulomb. So joule per coulomb is called volt. This unit is named after the famous scientist Sir Alessandro Volta, who was pioneer in inventing the first ever cell, the voltaic cell, about which we have studied in class 8. So in his honor, the name of the unit of electric potential is called volt. Now inside any conductor, all the electrons are moving randomly in all possible directions. If we find the resultant velocity of the electrons, it turns out to be 0. Velocity being a vector quantity, we all know that direction also plays a very important role. Now to maintain a directed flow of charge, this means all the electrons need to move in one direction, we have to apply some external energy. That external energy is provided by the cell or battery. This battery helps to ensure that all the electrons start moving in one direction. In the picture, you can see a cell, that is the source of current, that is providing a voltage, or what is called the potential difference, that helps to make the electrons flow in one direction. Now, one question arises, what is this potential difference? About what kind of a difference we are talking of? For understanding this, you can take help of this picture. You can see the setup of a simple structure that is similar to that of a water fountain, where water is being pumped. The same water is flowing through this entire setup again and again. How is this entire setup ensuring the flow of water through it continuously? By maintaining a difference. Difference of what? Difference in pressure. You can see there is a region of high pressure and then there is a region of low pressure. Using the pump, we can ensure that the pressure difference is maintained, and that pressure difference will maintain the steady flow of water. As the pump was ensuring the steady flow of water through the setup, a similar action is done by the battery. You can see in place of pump, the word battery has been substituted, and how the battery is ensuring a steady flow of charges through the entire setup. It has maintained a difference in gradient. You can see using that red arrow, a slope has been shown in which one point is situated on the top and one point is shown in the bottom. So how the charges are flowing from a peak point, that is at a point with a certain height, to a lower height point. Now this difference in height is actually similar to the difference in what is called potential. So a potential difference is important. This needs to be maintained so as to ensure a steady flow of current. So potential difference, how to define it? It is the amount of work done in bringing unit positive charge from one point to another point in an electric field. It is a scalar quantity, and again its unit is joule per coulomb or volt. Now, what difference is it talking about and how we can mathematically write down an expression for it? You can see in the picture that the charge is being brought from infinity to A. So we can write down the work done as WA. Similarly, you can see that the charge is being also brought from infinity to a point B. So we can write down the work done, corresponding work done, as WB. Now, in order to find out the difference, we need to subtract these two values. And what is the magnitude of charge brought from infinity to these 2 points? If that charge is denoted by Q, then WA minus WB divided by Q gives us the value of potential difference, and that is the mathematical expression for potential difference. Potential difference is necessary to be maintained for getting a steady flow of current, and this is actually responsible for the directed flow of charges. How is it measured? It is measured by a device called voltmeter. This is how a voltmeter is connected in any circuit. It is similar in structure to that of an ammeter. It has got a positive and negative terminal. The only difference is the manner in which it needs to be connected. It is always connected in parallel. How a parallel connection is done, that you can see in the picture. Voltmeters must be connected in parallel, and the positive side of voltmeter is connected to the positive terminal of the cell or battery, and vice versa. The adjoining picture shows the circuit diagram. How we are going to draw the circuit diagram, that will be discussed in the next session. We will discuss about the circuit symbols in detail, and that will help us to draw the circuit diagrams properly. So we will end today's session up till this much only, and your assignment for today will be to remember all the topics that we have studied up till now. Thank you.